AI feels digital, weightless, cloud-based, invisible, like something that exists only inside a screen and nowhere else. But that perception is misleading. Every AI query, every generated image, every automated decision runs through physical machines located in real buildings connected to real electrical grids. Those machines consume electricity continuously. They generate heat continuously. They require cooling continuously. And cooling at scale often requires water. This is not just a software revolution. It is an infrastructure shift hiding behind a digital interface. The word cloud abstracts reality. It makes computation feel frictionless. But the cloud is steel racks stacked in long corridors. It is high-density processors mounted inside controlled environments. It is fiber lines buried under roads. It is backup generators waiting for outages. It is substations converting voltage. It is zoning approvals and land acquisition. It is water routing systems and cooling towers. When you remove the branding language, what remains is heavy industry disguised as software. The public narrative focuses on automation, AI replacing jobs, AI writing code, AI generating art, AI reshaping labor markets. But intelligence at scale is computational intensity. Computational intensity is energy intensity. And energy intensity reshapes economies. Historically, every leap in industrial capability required a parallel leap in energy infrastructure. Steam required coal. Electrification required massive grid expansion. The internet required fiber optics and switching centers. AI requires electricity and cooling at unprecedented density. Training advanced AI models consumes enormous amounts of electricity, not residential levels, grid scale levels, and inference at global scale requires persistent compute availability. That means power demand is not just episodic during training cycles, it becomes structural. Utilities across multiple regions are now forecasting load growth driven specifically by data center expansion. Transmission lines that once supported predictable regional demand are being evaluated for upgrade. Substations are being expanded. Generation capacity discussions are accelerating. This is not hype, it is capital allocation. If AI deployment scales across enterprise systems, defense infrastructure, finance, logistics, healthcare, manufacturing, and education simultaneously, the aggregate compute demand compounds. Compounding demand does not remain digital. It translates into physical strain on power generation and distribution systems. Regions with surplus capacity become strategic. Regions with constrained grids face difficult trade-offs. Energy pricing becomes sensitive to data center density. Infrastructure becomes leverage. But electricity alone is not enough. Compute generates heat. Heat destabilizes systems if unmanaged. Cooling architecture becomes essential to stability. Many large facilities rely on evaporative cooling or water-based systems. Millions of gallons annually can be cycled through a single major campus depending on climate and configuration. In water-stressed regions, that becomes a serious planning variable. Technology does not escape ecological constraints. It operates inside them. Water has always been strategic. Civilizations formed around it. Industry depended on it. Agriculture scales because of it. Now high-density computation depends on it as well. That does not mean catastrophe. It means interdependence. The expansion of digital intelligence is tethered to physical resources. And when digital systems scale faster than infrastructure planning cycles, pressure builds quietly. Now widen the lens. AI is not confined to chat interfaces. It is embedding itself into logistics routing, predictive maintenance systems, fraud detection, military analysis, scientific research, medical diagnostics, financial modeling, and autonomous systems. That means compute demand is not seasonal, it is infrastructural. When something becomes infrastructural, capital reorganizes around it. Look carefully at where capital is flowing. Utility companies expanding generation capacity. Semiconductor fabrication facilities receiving public subsidies. Energy grid modernization initiatives gaining momentum. Conversations around nuclear energy resurfacing after years of dormancy. Private equity targeting land near high-capacity transmission corridors. Cooling technology innovation accelerating in the background. These are not isolated headlines. They form a pattern. Patterns in capital allocation are signals. Markets often anticipate bottlenecks before they appear in mainstream discussion. When sustained investment flows into energy infrastructure while AI adoption accelerates, the linkage becomes clear. Compute is leverage. Energy enables compute. Water stabilizes compute. Whoever controls those enabling layers influences everything built above them. This does not imply hidden masterminds. It implies incentives. Corporations pursue growth. Governments pursue strategic advantage. Investors pursue returns. When AI becomes synonymous with productivity, military readiness, and economic competitiveness, infrastructure becomes national interest. Energy policy intersects with technology policy. Water management intersects with industrial expansion. Historically, infrastructure transitions create winners and laggards. Regions that adapt early attract disproportionate capital. Regions that delay fall behind. During electrification, industrial centers surged ahead. During broadband expansion, digitally connected regions accelerated economic growth. Now, regions capable of supporting high-density compute will attract capital, talent, and long-term development. The risk is not AI itself. The risk is misreading the shift. If public discourse remains focused only on applications and surface-level automation debates, then resource planning lags deployment. That lag creates friction. Friction manifests as pricing volatility, regulatory tension, community resistance, and reactive policy making. Understanding infrastructure early allows positioning rather than reaction. There is also an upside. AI can improve grid efficiency through predictive load balancing. It can optimize water management systems. It can reduce waste in industrial processes. It can enhance maintenance cycles for critical infrastructure. The same force increasing demand can increase coordination. The trajectory depends on governance, planning, and capital discipline. But discipline requires awareness. Awareness requires looking upstream. Most people evaluate AI by interface experience. Very few evaluate it by megawatt projections. Very few examine cooling system design. Very few track transmission line upgrades. Yet those layers determine scalability. Those layers determine constraints, and constraints determine pricing power. When capital consistently flows toward energy expansion, cooling innovation, semiconductor concentration, and land near power infrastructure, it signals that the shift is structural. Structural shifts redefine economic gravity. They reshape supply chains. They influence geopolitics. They alter investment cycles. And they often do so quietly before public consensus catches up. AI is not floating in the cloud. It is anchored to grids, pipelines, reservoirs, and supply chains. It is bound by physics and constrained by geography. As adoption deepens, those constraints become strategic variables. Energy becomes more than a utility. Water becomes more than a background resource. Infrastructure becomes central. If you focus only on what AI can produce, you remain downstream. If you monitor where energy contracts are signed, where cooling systems are built, where grid upgrades are financed, and where capital concentrates, you move upstream. AI is not just code. It is energy, it is water, it is land, it is infrastructure, and the quiet shift is happening at that layer. The loud story is intelligence. The quiet story is capacity. The loud story is automation. The quiet story is allocation. The loud story is disruption. The quiet story is infrastructure. And infrastructure always tells the truth about where power is moving.